This is Unit 8, Lesson 3, Learning Target. I can factor polynomials by using various mathematical practices. Don't worry about that homework, of course. And the do now is right there. Remember, it's asking for the area of the triangle, and it's an expression. So you're not going to come out with a number answer here. It's going to be an expression. So go ahead and use that area triangle, area formula. Area equals half base times height. This is like the question 14, I think it was on the homework yesterday. Go ahead and see if you can do that. Press pause now. So we have, and by the way, every time I have a half, I just put 0.5. So it's 0.5 times base times height. It doesn't matter what you put for the base and height, actually. The base is actually 4x plus 2, and the height is 2x minus 2. And since multiplication is commutative, doesn't matter which way you multiply it. But let's go ahead and do multiply the binomials, and we could actually multiply them like this using distributive property. So I have 2x times 4x, and that is 8. And in my head, I'm doing 2 times 4 first, and I get 8, and it's squared. Then I am going to distribute the 2x to the 2, and that's 2x times 2, and that is 4x. And next I have negative 2 times 4, negative 2 times 4, I'm sorry, negative 2 times 4x, and that is negative 8x. And the last thing that I have to distribute is that negative 2 to the 2, and that is negative 4x. So just before I go ahead and multiply this 0.5, I have to combine like terms. The like terms will always be in the middle if you do it this way with the distributive property or FOIL or whatever. So I have 8x squared. I'm going to bring that down, and I'm going to do 4 minus 8, and that is negative 4x. Hopefully you did that. And I did make a mistake here. Negative 2 times positive 2 is negative 4. So I'm just going to bring that down as well. Now I'm going to put the parentheses back, and I'm going to put this 0.5 back. So when you're multiplying by a half, obviously you're going to half all the numbers, and that's all that's going to happen. So when you distribute, you're going to distribute this 0.5 to the 8x squared, and you're going to get 4x squared. And then you're going to distribute this 0.5 to this negative 4x, and that's negative 2x. And one last thing to distribute. You have 0.5 times a negative 4, and that's a negative 2. So your answer is 4x squared minus 2x minus 2. And this is your answer. That is the expression to find the area of this triangle. And that's it. So your page probably looks a little bit different than this, and I just wanted to take you through, your page probably looks like this, right? But I wanted to take you through, and you don't really have to do anything, you just kind of just watch what I'm doing. This is called factoring, and factoring is, I like to think about factoring as going in reverse of what you've been doing with the multiplication. So the GCF, which is called the is the greatest common factor of the coefficients. Everybody knows what greatest common factor is, but with exponents, the way it works, as far as the variable, it always will be the greatest common factor. When you're talking about exponents, you're talking about the smallest exponent will always be the greatest common factor of that variable. All right, so we'll just do this one right here, and I'll just show you exactly how I would factor this polynomial. As soon as I see this polynomial, what I do is I put parentheses down, like that, right? And outside the parentheses, this kind of be like distributive property in reverse. All right, I'm going to take a look at just the numbers first. And I'm going to look at the numbers and I'm going to ask myself, what is the greatest number that goes into all three of those numbers? What is the greatest number that goes into all of just the numbers? So 12, negative 20, I'm not even looking at positive negatives, but 12, 20, and 8. So if you said, all right, you're thinking like you're going to start 2. 2 goes into all, but it's not the greatest number. All right, it's not the greatest common factor. So let's move it up. 4. 4 goes into 12, 4 goes into 20, and 4 goes into 8. Let's see if 6, no, 6 can't go, nope, 6 can't work. 8, 8 goes into 8, but 8 doesn't go into 20. So what we're looking at is 4. So what I do is I just put the 4 on the outside, right? And I leave a little space like that because I know that I am going to take out an x, right? So I have x to the fourth, I have x to the second, and I have x. And just like this says, the variable with the smallest exponent is the greatest common factor of that variable. So you're talking about this x right here. If you think about the way distributive property works, this right here is the greatest common factor of that variable. So when I put the x on the outside, I'm going to do this, I'm going to like think about, all right, distributive property in reverse. So I have this 4x out here. Now I have to ask myself, all right, what times 4 equals 12? Right? What times this 4 equals 12? If you said 3, you're correct. But what times the x equals x to the fourth? Right? So if you have x times x to the third, that equals x to the fourth. Now think about it. 4 times 3 is 12. X times x, x to the third is x to the fourth. This is good. Now we'll move on to the next one. And since it's a negative 20, I'm going to put that minus sign right there. So I'm going to start again. 4 times what equals negative 20? 4 times what? 4 times 5. And I'm just taking the numbers, right? And then I'm going to move over to the x. X times what? What do I have to put here to make it equal to x squared? X times x. So now think about it. You have 4 times negative 5 is negative 20. X times x equals x squared. It's like doing distributive property in reverse. It's the same exact thing. So now you know that it's going to be a plus. Four times what equals 8? 4 times what equals 8? That's 2. X times what equals x? Well, you don't have to put anything there. It's x. So think about it. If you did distributive property over again, if you took this over again, you don't have to do this, but I'm just saying this is how you would check it. 4x times 3x to the third is 12x to the fourth. If you do distributive property, you should come out with what you have up here. 4x times negative 5x. 4x times negative 5x. 4 times negative 5 is 20. X times x is x squared. So far, so good. And then 4x times 2 is 8x. That checks out. So I kind of checked it. I checked myself. But this is the answer. What you have here is the answer. Let me move that up. All right, it says when it says factor the polynomial, this is factored. And I checked it using distributive property. I just checked it using distributive property and it works out. Remember, the greatest common factor, go for the numbers first. You're talking about the greatest common factor. So I underline all the numbers first, the coefficients. So if I have 12, 20, and 8, 4 is the greatest number that could go into all three of those numbers. And then you're moving over to x to the fourth, x to the second, and x. It's always the smallest exponent that comes out for that variable. All right. So x to the first goes into x to the second. It goes into x to the fourth. So let's move on to the next page. And this was set up right here. It's the same problem. So I'm just going to move along. This table shows you a step-by-step of what needs to be done, but I kind of go from here to here. All right. This is just showing you that a step-by-step of what we just did, the greatest common factor and everything. And also, everybody, just remember that every time that you write something, it has to be written in standard form. Standard form is the largest exponent first, followed by the next, the one that's right below it, and the one that's below that. Check your answer using distributive property. The factored form, like we did in the other page, is this. That's the factored form. And we're going to go and do a couple of them together now. So number one, the first thing that I would do is set up parentheses. I don't know why my parentheses down there. The first thing I would do is set up parentheses, right, and make them large. All right, so you have parentheses like that. All right, I'm going to underline the numbers only, the coefficients. All right. Okay, so think of a number. You could use your calculator, but these numbers are pretty easy. What number is the greatest common factor that goes into 15, 10, 40? If you said 10, that's not it, because 10 cannot go into 15. What goes into 15, 10, and 40, the greatest number? If you said 5, You are correct. All right, now I'm going to look at the x's. X to the fifth, x to the third, and look, there's no x here. So if you were doing distributive property, if you put an x out here and you were doing distributive property to this last number, you would get like 40x, and you don't have that here. So there is no, in greatest common factor, it's just 5, because not all of the terms have an x. So you can't take that x out. The greatest common factor is just that. When you're talking about factors, you're talking about every single number, a greatest common factor. And x is not a common factor because 40 is just 40 and not 40x. So let's go ahead and just do the distributive property again in our heads. 5 times what number equals 15? 5 times 3 equals 15. And since we have no x out here, you're just going to copy that x to the fifth down. 5 times what equals negative 10? 5 times negative 2 equals negative 10. And this x to the third just comes down. 5 times what equals positive 40? 5 times 8. Almost forgot my multiplication table. 5 times 8 is 40. And that's about it. So if you were going to check this using distributive property, all right, you're going to check. So and that's what the directions say to do. We're going to just do 5 times negative 5 times 3 x to the fifth, and that's 15 x to the fifth. Then we have 5 times negative 2x to the third, and that is negative 10x to the third. And one more, we have 5 times 8, and I forgot to put that there, 5 times 8, and that is plus 40. And that is correct, it checks out. All right, we'll do this next one, and you could try to take number 3 on your own. So we have 8z to the fourth plus z to the seventh. Okay, set up your parentheses. Okay, taking a look at the numbers first. 8 and 1. Well, we don't bring a 1 out. We just don't bring a 1 out, but there's no number here. There's no greatest common factor as far as the coefficients are concerned. But what about the z to the fourth and the z to the seventh? What is the greatest common factor of z to the fourth and z to the seventh? It is z to the fourth. Greatest common factor. And if I could just go back to the other page for a second. Okay, remember it says the variable with the smallest exponent will always be the greatest common factor of that variable. The variable with the smallest exponent will always be the greatest common factor of that exponent. So the variable with the smallest exponent, so that z to the fourth is the greatest common factor. So z to the fourth times what equals 8z to the fourth? If you said 8, that's correct. Z to the fourth times 8 equals 8z to the fourth. Z to the fourth times what equals z to the seventh? This is where you remember your laws of exponents. When you multiply, what do you do with the exponents? You add them. So z to the fourth times z to the what equals z to the seventh, z to the third. If you distribute, it's pretty easy. It is 8z to the fourth. That's not 82. I'm going to put that's a z. And z to the fourth times z to the third is z to the seventh. And that's just checking distributive property, doing distributive property in my head. I do it like when you get good at it, you just do it as it goes. Try number 3 and see what you can get. Try number 3 on your own. Press pause now. Okay, so what we have here for negative 6x squared minus 3x. So you're looking at just the numbers first, coefficients, I should say. So out of 6, out of that negative 6 and that negative 3, what is the greatest common factor that you can pull out? The greatest common factor. Right? If you said 3, you're correct. But it's not only a 3, it's a negative 3. Because both of these are negative, that's it. They do have a common, negative 3 goes into negative 6, and negative 3 goes into a negative 3, obviously. But now we're looking at the x squareds and the x. What's the greatest common factor? Just x. Because remember, what we put up here, the variable with the smallest exponent will always be the greatest common factor for that variable. Right? So the smallest exponent, that's what it comes out all the time. Right? You have negative 3x. So now when you do distributive property, it should work out. Negative 3 times what equals negative 6? 2. X times what equals x? X. Negative 3 times what equals negative 3? Negative 3x times what equals negative 3x? Plus 1. So now if you put something down that's wrong here, then you could actually go check it. So we have negative 3x times 2x, and that is negative 6x squared. Just to check it using distributive property. And then negative 3x times 1 is negative 3x. And that's exactly what we have. Always good to check it using distributive property. That last step, I mean, like obviously you don't have to check it every single time, but I think you really should. So that's basically how you do that. All right, next page, there's a lot of questions here, all right, to practice. So there's 9. I'm going to do like maybe one or two, I'm going to do 2 of them with you. I'll do the first, yeah, whatever. We're going to do a couple together, and then we'll press pause and see if you can, you know, kind of work on it on your own, because it's something that you definitely need to know as far as factoring goes and stuff like that. Very important. But the first thing when I look at this, I put down some parentheses, right? So I can put down the parentheses right there, and I'm going to need a little bit more room. So obviously a number is going to go out here, greatest common factor is going to go out here, and all the terms inside are basically going to be, I'm going to just be doing distributive property in reverse in my head, right? So what number goes into all of these numbers here? So if you're thinking that 3, I have to get my calculator up. I'm thinking that 3 might go in, but it doesn't. Like, right? So, like, if I just check really quickly, if 3 goes into 10, obviously it doesn't. If 3 goes into 35, it doesn't. So I know that's not a greatest common factor, and that means there is no number, as far as we can tell, that goes into 3, 10, and 35. So nothing gets pulled out. So now I'm going to go to the next to see if there's a greatest common factor with the y's, and there is. Y. That gets pulled out. So let's do distributive property in reverse. Y times what equals 35y to the sixth? Well, this is pretty easy because now obviously it's y times 35, but what times y equals y to the sixth? Y to the what? Remember, you add exponents. Y to the fifth. What times y equals 10y to 10y squared? Obviously 10 times y equals 10y, but y times what equals y squared? Y. If you do it in your head, y times 10y, y times 10y is 10y squared. Y times what equals negative 3y? Well, negative 3. And that's it. You could just do distributive property y times 35y to the fifth. That's 35y to the sixth. Y times 10y is 10y squared. Y times negative 3 is negative 3y. Let's go over here now and start number 2. Go ahead and basically set up the parentheses and get the greatest common factor, and then we'll come back and we'll do it together. All right, just do that part. Press pause now. So you're looking at the numbers first. Obviously the 8, 8, and 8. So 8 definitely comes out. But what about the z's? Z squared, z, and there's no z here. So the greatest common factor is just 8. Now we could just kind of ask yourself, all right, what times 8 equals 8z squared? Well, z squared. And if you're unsure of what you're putting down, just do distributive. 8 times z squared is 8z squared. That's good. Now this is negative, so positive times a negative would be a negative. So 8 times what equals 8z? 8 times what? Z. If you're unsure, 8 times negative z is negative 8z. And then what times 8 equals 8? Obviously 1. Can't leave it blank. Right? 8 times 1 equals 8. Do distributive property, just, I'm putting these little slash marks for z. Alright, so take a look at number 3, and then you could do the rest on your own. So number 3, I'm going to underline the numbers first. Is there a number that goes into both 7 and 15? No. There's no greatest common factor. Do both of the numbers have x? No. So what is going to happen with this is nothing. This is not factorable. All right, so you're talking about something that cannot be factored. So that means when you can't factor something, it stays exactly like it is. There is no greatest common factor that could come out of 15 and so just looking at the numbers, 15 and 7, 7 and 15. All right, so 7, there's nothing. So x to the fourth, if the 7 had an x, maybe you could take it out because then it would have a factor that is common. But it doesn't, and that means that you don't take anything out, not factorable. All right, so go ahead and press pause now. We'll come back with 4, 5, and 6. Press pause now. So, number 4, looking at number 4, I, since they're both negative, and right, just taking in the numbers, the coefficients, there's no greatest common factor as far as numbers go. It goes into 6 and 20. But we have p here and we have p squared here. So p is coming out as a greatest common factor. And since they're both negative, I'm going to take that negative p out as well. Now think negative p times what equals negative 20p squared. Negative times a positive 20p equals negative 20p squared. Negative p times what equals negative 6p. That's positive 6. And you do distributive property to check it, you get exactly what number 4 started as. Number 5, looking at the numbers as far as the coefficients go, there are no greatest common factor numbers. But there's x to the third, x to the second, and x. So they do have common factors, and x to the first is the one that comes out. Because x to the first goes into x to the third and x to the second. So x times what equals 3x to the third? X times 3x squared equals 3x to the third. X times what equals 2x squared? X times 2x equals 2x squared. X times negative 1 equals negative x. So, talking about number 6, we're talking about numbers here, all right, coefficients. So 5 goes into 5, 20, and 40. It's the greatest common factor. Then looking at the variable with the exponents, the smallest variable is x squared. That's the greatest common factor here. So 5x squared times what equals 40x to the ninth. 5 times 8 is 40. X squared times what equals x to the ninth. X squared times x to the seventh equals x to the ninth. 5 times what equals 20. 5 times 4 equals 20. X squared times what equals x to the third, x to the fifth. X to the third times x squared equals x to the fifth. 5 times what equals 5x squared. 5x squared times what equals 5x squared. Obviously it's 1. All right, go ahead and press pause again and do 7, 8, and 9. See if you can get that done. All right, press pause now. So taking a look at number 7, I just wanted to go over number 7. You're going to underline this. Is basically take it slow. All right, you're going to underline these numbers. So you have a greatest common factor of the coefficients. What number goes into, what's the greatest number that goes into 12, 3, and 9? Well, it's 3. That's the greatest number. Then x to the fifth, x to the third, x. What's the smallest exponent for that variable? Well, it's x. That's what comes out. So now 3x times what equals 12x to the fifth. I like to do this like one step at a time. 3 times what equals 12? That's 4. What times x equals x to the 5th? Adding exponents, it's x to the 4th. 3 times what equals negative 3? That's negative 1, but I don't have to put it. X times what equals x to the 3rd? Remember, I have to have that negative there because it's positive times, you have to have a negative answer. So positive times a negative would be a negative. So x times what equals x to the 3rd? X squared. You could check it as you go. 3x times negative x squared equals negative 3x to the 3rd. 3 times what equals 9? 3 times 3 equals 9. And the x just comes along. This is just x. So 3x times 3 equals 9x. And that is your final answer. All right, take it slow, one step at a time, put the parentheses down, get the greatest common factor of the coefficient first, and then see if there's a variable that can be taken out as the greatest common factor as well. Remember, the greatest common factor of the variables, the exponent that is the least will be the one that's coming out as the greatest common factor. All right, so go ahead, try number 8 and number 9 on your own, and then we'll come back and talk about the answers. Press pause now. All right, so let's go over number 8 and number 9. Oh, it's so much fun. So you're taking the coefficient, looking at the numbers. 12 does go into 48 just to check, just to make sure 48 divided by 12. See if it goes in. Yes, it does. It goes into 4, and that's it. So 12 comes out, and then you go to a to the 9th and a to the 4th, and the smallest exponent for that variable is that a to the 4th. That comes out. That's the greatest common factor. 12a to the 4th times what equals 48a to the 9th. So I take 12 times 4 is 48. A to the 4th times what equals a to the 9th, a to the 5th. So 12a to the 4th times 4a to the 5th is 48a to the 9th. And then 12a to the 4th is right here. So 12a to the 4th times 1 equals 12a to the 4th. Taking number 9, you're taking a look at, obviously 2 comes out, so because that's the greatest common factor, and then n squared and n comes out. So 2n times what equals 2n squared? 2n times n equals 2n squared. 2n times negative 1 equals negative 2n. And that's basically it for number 9. Right? So now we have a school sign that the area in square feet of the school sign can be represented by 15x squared minus 6x. Write the expression that represents the length of the sign. So they gave you the width. So describe 2 ways to find the area of the sign when x equals 2. And that's basically it. So think about like how you would figure this out if the area, because remember what you need here, the area of a rectangle of this school sign is what? Like you're gonna put down the area formula, and that's length times width, and hopefully you do know that. So if it's length times width, so you just basically gonna need what they're giving you the answer. All right, they're giving you the area. So that's the way I would start out using this and kind of fill in, substitute what they give you into this formula and see if you could rework the formula to solve for the length. All right, press pause now. So just take a look at what I was saying before. You're talking about this. The area is given to you, right? So you're going to substitute that 15x squared minus 6x into the area section of this formula. Equal sign comes down, the length is missing, right? So we want to solve for that length, and the length is here. That's an L, by the way, times the width, which is 3x. So think about your algebra skills. What would you do to both sides to solve for L? And if you said that, well, think about it. Like, how would you get this 3x to cancel and then L be left alone on this side right here? So if you said divide by the 3x, you're correct. All right, so you're dividing by 3x on both sides, and that's how you would get the L alone. Because what happens is that whatever you want to solve for, that's what you have to divide. Like whatever you want to solve for, you have to divide by everything else that's on that side. So we're talking about now the L coming down, the length coming down, and you're dividing by this 3x. So let's, in one step at a time, we have, and just remember, 15 divided by 3 is 5. X squared divided by x. Does anybody remember the laws of exponents? When you divide, what do you do with the exponents? You subtract them. Then you move over and it's negative 6 divided by 3. And that's negative 2. And then x divided by x, you just leave it. So negative 6x divided by 3x. That cancels each other out. And L is, believe it or not, 5x minus 2. You got it. And that's your length. Length equals 5x minus 2. So the second part of the question asks you for two methods to describe ways that you can find the area of the sign. Pretty easy, because now I'm going to take this and I am going to, if it works, I'm going to take this L away. All right, I'm going to put 5x minus 2 down as the length. And obviously you're going to substitute this x in and then figure out what the area is based on this formula. So we have 5x, area equals length times width. So you could do it two different ways. You could either substitute the 2 in beginning and then get numbers out of it, and that's probably the way I would go. So method 1, or number 1, I would just go ahead and substitute in. So we have both, we have the length and we have the width. So I'm just going to take the 5x, and then for x, I'm going to put the 2 in, because that's what it's given me as the x minus 2. So I know that the length, when I do 5 times 2 minus 2, is 8. And then the 3x is 3 times 2. So I know that the width is 6. So the length is 8. The width equals 6. Just I need to have that down there. And then you just use the formula A equals, and this A equals 8 times 6. And A that's one way you could do it. Right? And then the second way you could do this is to actually do multiply 5x. We're going to go through this in a second. Let me press pause. Second way you could do this is actually just put the formula A equals L times W and do this first. So you have 5x minus 2 and times that 3x. So you could do it this way, and you could either substitute before or after. You could do distributive property and get 15x squared. Well, do distributive property and we'll come back with the answer. So press pause now. So there's the second method that I was trying to say. Length times width, you can multiply the binomial and the monomial, and then you get 15x squared because it's 3x times 5x, 15x squared times 3x minus times negative 2, and that's 6x, negative 6x, and then substitute the numbers in. It just comes down to substitution, and you get the same exact thing. Remember, when you substitute the 2 in for that x, it's only the 2 that's being squared, so that would be 15 times 4 minus 12. 15 times 4 is 60. 60 minus 12 is 48 feet squared as the area, and that's basically it. Okay, so factoring quadratics, a little bit different. This quadratic is in the form of x squared plus bx, b times x plus c equals 0. That is the quadratic. An example of that is something like this: x squared plus 4x minus 12. And so as soon as I see something like this, it's a quadratic, I know that to write down two sets of parentheses. And the reason why is because a quadratic is basically going to be the answer to when you multiply two binomials. Not every single time, but most of the time. All right. So we have x squared plus 4x minus 12. And the first thing that you do is put x times x down. Because remember, when you're doing distributive property, x times x is x squared. So now I look at these two numbers. And you know that you have to pick two numbers that multiply to 12. And it not only has to be multiplied to 12, it has to be multiplied to negative 12. Right? So two numbers that have to multiply to 12 and they have to add to 4. Right? So I worry about, I don't pick the numbers, I pick the numbers first. I don't worry about the signs until later. So I know that two numbers that multiply to 12 could be 4 times 3. That's what pops into my head first. Obviously, you could use 12 times 1, right? And then also you could use 6 times 2. So like 12 is a little bit difficult number. So all of these numbers multiply to 12. And you notice that I'm not putting the signs down. I'm going to leave the signs until later. So I'm just going to pick what came to my head first. I'm going to pick 4 and 3. Now, I don't know if this is going to be the answer. Right? So I know 4 times 3 could equal 12. I'm not worried about the sign yet. But can 4 and 3 in any way add or subtract to 4? Well, 4 minus 3 is 1, negative 4 and negative 3. All right, so like 4 and 3 cannot make 4 in any way, shape, or form. So I picked the wrong two numbers. So I'm going to take those out. And I know that these are not my factors. 12 and 1. 12 times 1 equals 12, but the thing is, can you make 4 if you add or subtract them? No, you can't. You can either make 11, right? 12 minus 1, or 13, negative and negative, all right? Or positive and positive. 6 and 2. Only one left, so I'm going to just put that in because I think that's what my answer is. 6 and 2. So 6 times 2 is 12. And I could do 6 minus 2 to make 4. Positive 4. All right, now I'm looking. All right, so now I have to multiply to make a negative. Right, so if I have to multiply to make a negative, that means one of them has to be positive and one of them has to be negative. I know that. Right, and to add or subtract to a positive 4, all right, which one has to be positive, which one has to be negative? So let's just take a look. If I put positive here and I put negative here, let's see what happens. 6 times negative 2. 6 times negative 2 is negative 12. 6 minus 2 is 4. So let's just take a look. X times x is x squared. That's x squared. Let's see if we're right. X times negative 2 is negative 2x. Okay. 6 times x is 6x. And 6 times negative 2 is negative 12. If you combine like terms right here in the middle, that would come out to be x squared plus 4x minus 12. And that's basically how I go through it. It'll get easier as you go. But here's some notes that you could kind of read and everything. And I'm not going to read them to you because, again, that's basically how you would go through it. You could read that on your own. So going to the next page, there's more notes right here for you. Please read them. Very important. So just taking a look, if I had this answer, this first. So if I had x squared, let me just put this down. This just goes through the same example that we just did, but I just wanted to just look at this result right here. Like when I get this as a question, and it says to factor it, I know that right away. I have to put down my two binomial parentheses. I know that x times x goes in the first because it's x squared. I look at that first. Then I look at this number and I try to pick my factors that multiply to that number. I don't worry about this number yet. Right? So when I'm picking my factors, I originally picked 4 times 3, and that would be wrong because 4 and 3 cannot make 4 if you add or subtract them. But 6 and 2 can. And it does matter where you put them, but it does matter what sign goes with that number. Right? So that's why I picked the sign basically last, but you could do it any way that you feel is easy for you. And when I kind of just take a look at it and say, all right, so now I have 12, right, that I have to multiply to, and saying that I know the factors, like this is my first step. I put the parentheses down and I know it's x and x, right? So, and then I know right now that it's 6 and 2. So I put 6 and 2 first, and for some reason I always put the larger number first. It's just easier for me to read that way. All right, for me. but you could put whatever you feel is comfortable for you. But I know that 6 minus 2 equals 4. 6 minus 2 equals 4. And if I put 6, this is a positive 6, minus 2. I didn't even really look at this negative 12. And then I could just kind of do distributive property here and figure out if I'm correct, or quickly do 6 times negative 2, because I know that's my last set of like distributive property that what I'm going to multiply. 6 times negative 2 is negative 12. 6 minus 2 is 4. So I'm okay. You could do the, like, basically go through distributive property. You know, x times x would be x squared. X times negative 2 would be negative 2x. 6 times x would be 6x. And then 6 times negative 2 would be negative 12. So what it would come out to be is in the middle, you would have negative 2x plus 6x, and that would be a 4x. And 6 times negative 2 is negative 12. So this is correct. All right. Use your distributive property or FOIL to check your answers. So there's a lot of practice problems right here. I'm going to take you through 2 of them, and then hopefully you can do some of the rest on your own, because this video is really pretty long. So when I see a quadratic like this, I know it's the product of 2 binomials being multiplied together, and I know x squared, looking at the x squared here, and it's x times x. Now I have to pick 2 numbers that multiply to 30 and that add to 11. Since this is all positives, since like everything is positive here, you know that both of them are going to be positive, right? Everything is positive. That means everything's positive down here. So what 2 numbers can multiply to 30? So look, 30 times 1, right? 15 times 2. And 6 times 5. Okay, so what 2 numbers out of these pairs can make 11 if you add them together? 30, this could make 31, or if you subtract them, can make 29. This could make 17, or if you subtract them, you can make 13. This could make 11 if you add them together. So this is 6 and 5. So if you go ahead and do x times x, that's x squared. X times 5 is 5x. 6 times x is 6x. 6 times 5 is 30. You're correct. The 6x and the 5x in the middle will add to 11x. And these are a little bit easier because, again, there's all addition here. So I'm going to put t and a plus and another t, because t squared is t times t and a plus. What 2 numbers multiply to 4 and add to 4? So 4 times 1, 2 times 2. So 4 times 1 will add to 5, or you can make 3 out of it. So you can't make 4 if you add them. 2 times 2. And you can check it. T times t, t squared. T times 2 is 2t. 2 times t is 2t. 2 times 2 is 4. The 2t plus 2t would be in the middle, and that's 4t. Again, I did 1, 5, which is not the correct way, but that's the way I did it. See if you could do number 2. Press pause now. Okay, hopefully you put y and y for number 2. And you're going to think about 2 numbers that multiply to 16. 8 and 2, 4 and 4, and 16 and 1. Yeah. So 16 and 1, all right, so now you're going to look, you're going to shift your eyes to 8, right? 16 and 1 can't make 8. 4 and 4 can make 8, 4 plus 4. 8 and 2, so if 8 minus 2 is 6, 8 plus 2, so this, it has to be 4 and 4, right? Has to be 4 and 4. That's out, that's out. I'm just going to put 4. You notice I'm not putting the signs down yet. I have to multiply to a positive. What are the two ways that you can multiply to a positive number? Positive times positive and negative times negative. But if you put positive times positive down, right? What's 4 plus 4? That's not negative 8. But if I put negative and negative, well, let me see. Negative 4 minus 4 is negative 8. Negative 4 times negative 4 is positive 16. Let's see if it works, though. So you have y times y is y squared. Y times negative 4 is negative 4y. Negative 4 times y is negative 4y. And negative 4 times negative 4 is 16. And if you look, I don't have any room to do it, but negative 4 minus 4y, negative 4y minus 4y is negative 8y. That works out. So when I take a look at this number, I say, all right, 16. I don't take a look at the positives yet, or negatives. I mean, you could do it a different way. It's fine. But I know that I could put my factors down, multiply into 16, 16 times 1, 4 times 4, 8 times 2. I could always pick the numbers that, all right, now I shift to this. I have to make 8 by either adding or subtracting. The only two numbers I can make with 16 and 1 are 15 and 17 if I add them or subtract them. 4 and 4, I could add them to get 8. 8 and 2, 6. So 4 and 4 is the only option. You could cross these out right away. Right? So you know it's 4 and 4. You just have to pick the signs now. So once you have the factors in place, I think it's easier to pick the signs after the fact. I think. All right. So look at number 6. Take a look at number 6. Obviously, you're going to put x and x here, and I want you to press pause right now and see if you could think of two numbers that multiply to 18, that you can multiply to 18, and that you could use to add or subtract to 7. Press pause now. Yeah. All right. So we have 18. 18 times 1, 9 times 2, 6 times 3. All right. So, but one of these you could use to, one of these pairs you could use to add or subtract to 7. It is not 18 and 1, because 18 plus 1 is 19 and 18 minus 1 is 17. That's out. 9 plus 2 is 10. 9 minus 2 is 7. So this could be a possible pair. 6, 3 is 9. And 6 minus 3 is 3. That's out. So it's definitely 9 and 2. See, at least you have the pairs down. Right? Now you could pick if it's positive, what number has to be positive, what number has to be negative. So take a look at this. You have to multiply to a negative 18 and add to a positive 7. Multiplying to a negative, you would have to have different signs. It would have to be positive times a negative. So which one of these numbers has to be positive if you have to get a positive 7 from it? All right? Now, I'm going to put negative 9 and a positive 2. take a look. Negative 9 times 2 is negative 18. Negative 9 plus 2 is negative 7. That does not work. So what I'm going to do is I'm going to change it. Plus, and I am going to change this to a minus. And let's see if that works. You're going to make that mistake. 9 times negative 2 is negative 18. 9 minus 2 is 7. That's correct. Right? Try number 3 and 7 on your own. Press pause now. So taking a look at number 3, you have r times r, and I looked at 40, and I listed all of the factors I could think of. 40 times 1, 8 times 5, 20 times 2, 10 times 4. There's a lot of factors that multiply 40. But I need one of these factors to, I need one pair of these factors to either add or subtract to 3. 40 and 1 can make 41. It could also make 39. No good. 8 and 5. 8, 9, 10, 11, 12, 13. Yes, I counted on my fingers. 13. Or 8 minus 5. 6, 7, 8. That's 3. That's good. 20 and 2 is 22 or 18. That's no good. And then this is 14 or 6. So that's no good. So it's definitely 8 and 5. 8 and 5. Remember, I have to multiply to a negative, so that means one has to be positive and one has to be negative. One has to be positive, one has to be negative. And I have to add or subtract to a negative 3. All right? So when you have a negative 3 that you have to add to, the larger number gets that negative. Remember, there has to be more negatives here. So it has to add or subtract to a negative 3. So I'm going to put a plus 8 and see how this works out. And a negative 5. 8 times negative 5 is negative 40. 8 minus 5 is positive 3. That's no good. So I'm going to change this to a positive, and I'm going to put this as a negative. And I'm going to go over it again. Negative 8 times positive 5 is negative 40. Negative 8 plus 5 is negative 3. If I do distributive property, it's r squared plus 5r minus 8r and then minus 40. And you know that 5r in the middle, combining like terms, 5r minus 8r equals something. Yep. It equals negative 3r. And that is your answer. So, taking a look at number 7. Taking a look at number 7, you're looking at, all right, you have 56. So I immediately go, all right, 56 times 1. But I'm just, when you really get good at this, there's a 1 here. Right? So that means the numbers that you pick, all right, have to be, like, it has to create 1. So that means that they're right next to consecutive numbers. Because there's no way 56 and 1, you can make 57 out of this or 55. So it has to be numbers that are consecutive, and the two factors that multiply to 56 are 8 and 7. All right, I can stop right there because that's what I think it is. 8 and 7. Right, I have to multiply to a negative, so that means one has to be positive, one has to be negative, and I have to add to when you combine these numbers, it has to equal a negative 1. So which one gets the negative, which one gets the positive? I'm going to put a negative here and a positive here, and let me see if that works out. Negative 8 times positive 7 is negative 56. Negative 8 plus 7 is negative 1. So if you do the distributive property all the way through, you'll get exactly what it is. Please do number 4 and number 8. Press pause now. So just take a look at number 4, k squared plus k minus 42. The first thing I noticed, all right, that 42, right? 42 times 1, 7 times 6, and 21 times 2. Just to make sure, like if you don't know your multiplication tables, this is where it's going to really be difficult for you, because remember, even though you still have the calculator, it's going to take you a longer time than a person that knows what factors 42 has. But you still have your calculator. It's just going to take you longer. So what happens right now is that you could pick 42, right, and you could divide it by like a number like 8, right? And you can see it's 5.25, so you can't use that. It has to be whole numbers, right? So now it's 42 divided by 7, and you get 6. So 7 times 6 would be 42, all right? So you could just check it out in your calculator, and that's how you could get your factors if you don't know your factors by heart. All right, so I know that, see, this is what I was telling you before about number 7. There's a 1 there, right? So that means the numbers have to be really close. 42 times 1, 42 plus 1 is 43. 42 minus 1 is 41. 21 plus 2 is 23, and 21 minus 2 is 19. So these are no good. Right? You need, when you have a 1k or 1x or whatever it is, 1 in the middle, you know the numbers are consecutive, right? So 7 and 6. And you know also that 7 minus 6 is 1, is a positive 1. So that I'm going to put this right off the bat, 7 minus 6. So just to check it out, x times x is x squared. X times negative 6 is negative 6x. 7 times x is 7x. And then 7 times negative 6 is negative 42. So this equals out. This is negative 6x plus 7x is 1x. So that works. You're perfect. All right, for number 8, hopefully you did it already. I put my factors down already. It's 20 times 1, 10 times 2, and 5 times 4. So you just have to use a number to get to 8, add or subtract to 8. So 20 plus 1 is 21. 20 minus 1 is 19. This is no good. 10 plus 2 is 12. 10 minus 2 is 8. That could be good. 5 times 4, 5 plus 4, 5 plus 4 is 9. 5 minus 4 is 1. So if this was a 1, you know that these are consecutive numbers. That would work. They don't. So I know 10 and 2. That's my pair. They have to multiply to a negative. So that means 1 has to be positive, 1 has to be negative, and has to add or subtract to a negative 8. So I'm just going to put positive 8, positive 10, and a negative 2, and let's see how it works out. Positive 10 times negative 2 is negative 20. 10 minus 2 is positive 8. That's not what I have. I have negative 8. So I am going to change that. I'm going to put a negative 10 and a positive 2. And you'll get the hang of, like when you see a negative 8, obviously the negative goes next to the sign of the larger number. All right, so that's basically how you do it. Check your work using FOIL all the time, and that's about it. These are Regents problems, and the Regents problems, you should really be really concentrating on these. See if you could do all 4, and we'll come back with the answers. Right? Show your work. press pause now. Okay, taking yourself through this, they you have to really just use the multiple choice to your benefit. 24 has a lot of factors, right? But remember that the factors that you pick have to make 10, add or subtract to 10. 24 and 1, that can't be, and that's actually not even a choice. So putting that down is not really necessary. 12 and 2 can make 10. All right, if you subtract those two numbers. So 12 and 2 work. 8 and 3 cannot, and that's not even a choice, so putting that down is not necessary. And 6 and 4 can, though. All right, so that's why it's a little bit difficult, this one, because 6 and 4 work as far as the factors go, and 12 and 2 could work as well. You have to remember, you have to multiply to a positive. So it either has to be negative times negative or positive times positive. And what you could do really here when I have choices like this, I just go ahead and FOIL each one, right? And see if it works. But you could do a quick, like, a quick multiplication. 12, so positive 12, like you don't have to do every step of FOIL, all right? Every step of distributive property. Positive times a negative would be a negative. That's out, right? Positive times a positive, that works. All right, so we're going to keep 3. Negative times a positive. That's positive. That would be a negative 24. That's out. Negative times negative. So you know that 6 and 4 are definitely going to be your choice because that's the only thing left, right? So how would you multiply to a positive with 6 and 4? It has to be negative times negative. And then negative 6 minus 4 would be negative 10. So this would be your answer. This one, if you did x squared, x times x, x times negative 4 is negative 4x. Negative 6 times x is negative 6x. And negative 6 times negative 4 is positive 24. And that would add up to be what this number 4 is. And this is. All right, so we'll go over here. Actually, we'll go over here. No, actually, we'll go over here. All right, David correctly factored the expression m squared minus 12m minus 64. So 64 and 1 is out. It's not part of the choices here. I have to multiply to a negative. All right, so if I multiply to a negative, negative times a negative, that's out. That would be positive 64. Negative 16 times 4, positive 4, could. So I'm going to put 3 down. Negative times a positive, yes, it could. Positive times negative, yes, it could. So the only one that I got out there is number 1. Now remember, you have to make a 12 out of the two factors. 8 and 8 cannot make 12. That's out. So it has to be either 3 or 4. So negative 16 times positive 4 is negative 64. Negative 16 plus 4 is negative 12. 3 is your answer. Negative 16 minus 4, I'm sorry, positive 16 minus 4 is positive 12. So this would be out. If you do distributive property all the way through, you see exactly what it is. So you really could do distributive property all the way through. And that's basically it. All right, so I don't really need these. So I have, what are the factors of this? And these are, this is a pretty easy question. It's just that, all right, it has to multiply to a positive 6. So that multiplies to a positive 6. That does not. 6 times negative 1 would not. Uh, this doesn't multiply to a positive. Negative 6 times positive 1, that's out. This multiplies to a positive. So which one of these would add to a negative 5? Positive and positive would equal positive 5. That's out. 2 is your answer. And if you do distributive property, you get x squared, x times x squared, x times negative 3, negative 3x. Negative 2 times x is negative 2x. And negative 2 times negative 3 is a positive 6. And that would be negative 5x in the middle when you combine it. All right, so the last one, you have x squared minus 14x plus 49 can be expressed as, so I'm just going to put down x and x. I need a 14, so these two are out, so it's definitely 7 and 7. I need to multiply to a positive 49, so it's either positive positive or negative negative. I have to add or subtract to a negative 14. So the only way to do that is this. All right, so let me just check though. X times x is x squared. X times negative 7 is negative 7x. Negative 7 times x, which is right in the middle, negative 7x. And then negative 7 times negative 7 is a positive 49. And that would equal this. Negative, this right here, negative 7x, and negative 7x would be negative 14x. All right, so this is out, that's out, because this is negative 7, positive 7. This is x plus 7 times x plus 7, that's out. This is x minus 7 times x minus 7, so 1 is your answer, and that is that. So try the exit slip, the two problems on the exit slip. Press pause now. Okay, the correct factorization of x squared minus 11x plus 18. You put your parentheses down. You see exactly what you have here. Remember, you have to add or subtract to an 11, so this does not work. And neither is this. So it has to be 9 and 2, and that's what you have in all of the choices. But it has to add, has to multiply to an 18. So what you have to pick is either a negative times a negative or a positive times a positive. And not even looking at this, but it has to be the same signs. This is out, this is out. All right, it's either this or this. So to add to a negative 11 or subtract to a negative 11, it has to be negative 2 minus 9. C is your answer. If you did distributive property, you would see exactly what that is. This would be all positives. Remember, if you have all positives here, you have all positives here. So this is out. So very tricky problem. Which expression is not equivalent to this mess? So I am just going to take the first one and start distributing. So which one's not equivalent? So you have negative 4x to the third, right? And then you have the x squared. And then you have negative, all right, and then you do distributive property, negative 6x. And then this is positive 8. That looks exactly the same. This one is good, so that's out. And then I'm going to do distributive property here. Negative 4x to the third. So far, so good. X times negative x is negative x squared. X times 6 is 6x, and this is plus 8. So this does not. It's a negative x squared, this is a positive x squared. B is your answer. I'm not going to do the rest of them, but if you did, I'm sure they would come out to this. The only one that's not equivalent, not equal to, is to this is B. And that is one long lesson. Hopefully it helped. And that's it. See ya next time.